Hello class, welcome back. Today we are going to talk about geometric transformations. We've been talking about that. That's been our unit. We've shown the actual transformations. We've shown how to actually calculate them or write them out using patty paper or different types of methods. But now we're going to talk about the actual rules. Okay, the rules of geometric transformations. That's our goal for today. We're going to identify the rules for our three types of transformations: translations, which is what we call the slide; rotation, which we said is a turn; or reflection, which is a flip. Okay, these are the types of rules we're going to discuss today. And specifically, today, we are looking at, again, these three types, and we're looking at the actual rules that are going to be used for any type of translation, rotation, or reflection. Let's look at the first example. A translation, as we said, is a slide, right? So here we have an example of a slide to the right, but that's any type of slide across the graph. We're not changing the shape, we're not shifting it, we're not turning it, we're not flipping it, we're just moving it, right? That's a translation. The next type of transformation we talked about was rotations, and this is an example of a 90-degree rotation, a counterclockwise. So anytime we talk about a rotation, we generally talk about counterclockwise, okay? And we said that this will always be a rotation across the origin. And then finally, we have an example here of a reflection. Sorry, let me get my screen out of there. A reflection, okay? And this was an example of a reflection across the y-axis, okay? So again, we'll talk about the actual rules. Now, what happens if we don't have a graph? This is where the rules will come into place. So we have our transformation rules here. This is for reflection over x-axis, y-axis translation, dilation, which we won't cover just yet. We'll do that in the next unit. Rotation counterclockwise or rotation 180 degrees. We'll look at all the types of rotations in today's presentation. Okay, again, we won't discuss dilations just yet. We'll get to that next unit, but the main three we're looking at are translations, reflections, and rotations. Okay, let's look at an example right over here. Translation rules. So we want to translate this 4 units to the right and 1 unit down. We want to shift this over to the right. And it's easy to do when we have a graph, but what if we didn't have a graph? And this is where these rules are going to come into place. My rule is we take the original point, x comma y, so whatever that value is, right? X comma y, we don't know what it is, but we're going to add a to x and we're going to add b to y, right? That horizontal shift is the a value. So if we're moving it to the left, it's going to be negative. If we move it to the right, it's going to be positive, just like any other type of value on the graph, right? If we're moving to the left, we're moving in a negative direction. If we looked at it from a number line standpoint, if we move to the left, the numbers become more and more negative. If we move to the right, numbers become positive, right? Larger positive values. Vertical shift, if it's going up, it's a positive value. If it's going down, it's a negative value. So as you can see here, what would be an example of this translation 4 units to the right and 1 unit down? And you should see that those 4 units to the right is a positive movement and that 1 unit down is a negative movement. So let's show this actual graph. This is the example here. Okay, this is the actual shift on the graph. But also let's look at the points on the graph. All right, and let's look specifically at y. So if we looked at the original point y, it was at -5, 1. When we shift this over, notice how now y prime is at -1, 0. And so that's where our rules will apply. So even if we didn't have the graph, we could have used this rule, right? xy then is translated to x plus a, and then y plus b. And in this case, a is +4, because as you said, we're moving to the right 4 units, and it's negative b, because we're moving down 1 unit. Okay, so we would look at it like this. This is the rule for just the y value. Y is -5, 1, and it was translated to y prime, which is -5 plus 4, and then the y value is 1 minus 1, which turns out to be this value that we have here, -1, 0. Okay, so this is our rule for translations. We add or subtract whatever the horizontal or vertical shift is that they give us at the beginning of the question. Okay? All right, let's check out rotations. Okay, so rotations are a little bit different. And if you notice, we have some different rules. If we're shifting it over 90 degrees about the origin, and remember, anytime we say 90, 80 degrees, we're saying counterclockwise. If we're going to move it across the origin 90 degrees counterclockwise, or it's the same as a 270 degree clockwise rotation. Why? Because a quarter turn to the left is the same as a 3/4 turn to the right. Our rule is going to be x comma y becomes negative y comma x. Interesting. Okay. And then a 270 degree rotation about the origin, or a 90 degree clockwise rotation, is going to have the rule x comma y becomes y comma negative x. And all we're saying there is we're going to switch those values, right? So the x value now becomes the y value, and then the y value becomes the x value, but we're going to change that sign. That's why we have a negative value there. Okay, and the rotation 180 degrees about the origin is shown here. All we're going to do is just go from x comma y to negative x comma negative y. And let's look at an example of that. A 180 degree rotation about the origin. So we're going to turn this all the way from here all the way across to the next step. So the rule is x comma y to negative x comma negative y. Keep in mind here, we're not saying that the signs are going to have to be negative. We're just saying that whatever that x value was, we're going to change that sign. Okay, so we might start off with some negative values. Our x and our y value might both be negative. But here, when we do a 180 degree rotation, we simply mean change the sign of whatever the original point was. Okay, so let's look here. This is the actual graph rotated, or excuse me, the actual shape rotated 180 degrees, right? Going from here to here, it looks a little bit different. And so our rule is x comma y becomes negative x comma negative y. If we look at one example, which is v, or v prime, v starts at 2 comma 0, right? And then it is then rotated to negative 2 comma 0. So we change the signs for both of them. Now, of course, 0 is neither positive nor negative, so we leave it as 0, but we change the sign of x in this case. Okay, and these are our rules for rotations. The final one we're going to look at is reflections. And first, there's two types of reflections we'll talk about in this class: a reflection across the x-axis and a reflection across the y-axis. We've mentioned this before. Let's first look at a reflection across the x-axis. So the rule here is x comma y becomes x comma negative y. Interesting. And again, what we mean there, as we show the actual graph, is that we're just going to change the sign of the y value. Well, why is that? If we look at the actual reflected shape, notice how nothing changes here. Nothing changes horizontally. The shapes are still in the same spots. The only thing that changed was they flipped over the x-axis. So something I always like to think of is if I'm reflecting or flipping across the x-axis, I change the sign of the y value. And it'll be the opposite for the next one we see. Okay, so again, the rule is x comma y becomes x comma negative y. And if I look at the original point, x is at negative 1 comma 1, x prime becomes negative 1 comma negative 1. All we did, same values, just change the sign. Okay, and that's a reflection across the x-axis. Finally, we're going to look at a reflection across the y-axis. And as I said, if I'm reflecting across the y-axis, now all we're going to do is change the sign of the x value. Doesn't mean that we're making it negative. It just means we're making the sign change. Okay? So if we're reflecting across the x-axis, change the sign of the y value. If we're reflecting across the y-axis, change the sign of the x value. Okay? So same shape. This time we're going to reflect across the y-axis. Notice how that shape gives us a little bit of a different value. Notice how all the points are in the same place, vertically. They're in the same exact place. They just shifted over horizontally. So again, if we look at our rule, the rule becomes x comma y now becomes negative x comma y, where x was negative 1 comma 1. Now we just change the sign of x, which in this case it started out as negative, right? Doesn't mean we're making the x negative, it just means we're changing the sign. Started out negative, now we make it positive. So our x prime is now 1 comma 1. Okay. Again, I showed just one example and just one point, but if we did this for all the points, you would notice that all of them would be correct because they all follow this same exact rule. All right. All right, guys, I hope you enjoyed this video, this explanation. If you have any questions, please feel free to email me, or you can definitely put in any questions into our Schoology discussion post. Otherwise, we will leave it there, and good luck on the independent practice.